roping with the spoken. I stock twine, the veil waist still sprayed down on the stop sign. Born a sin, they told us always been in the top.
Hello and welcome to the video on basic limit laws. Okay, so basically what we're going to do during this video is go over some limit laws that are essential to know when you're working with limits. So I'm going to call this kind of like a toolbox of limit laws. Okay, so in this toolbox, the first thing we have to have are conditions or assumptions that we begin with. So first of all, we're going to assume that the following is true. We're going to assume that the limit as x approaches c, so as x approaches some number, of f of x, and limit as x approaches c of some other function, okay? We're going to assume that these two limits exist, okay? So they aren't undefined or anything. So assuming this, then we can kind of just say or state 5 laws. On this one, I'm only going to state 5 because they're the basic limit laws. Okay, so the first one is going to be called the sum law. So sum as in we're adding two things. So this is going to be that the limit as x approaches c of f of x plus g of x. So the limit of these, the sum of these combined functions exists. We can say that, and we know that so I'll rewrite it here again. So the limit as x approaches c of f of x plus g of x is basically going to be the same thing as the individual limits, but just added together. So calculated separately, limit of f of x plus the limit as x approaches c of g of x. Okay, so we just split it up with this addition sign here, okay, into two different quantities. All right, so that was the sum law. And now we'll go over number 2. This is going to be called the constant multiple law. Constant multiple law. Okay, and constant multiple in this sense, meaning constant as in just a number, something that stays constant, aka the opposite of a variable, right? So something that's constant, and then we're going to multiply it times a function. So for this, we can say that assuming the top up here, so assuming this starred thing, then limit as x approaches c of k, which is a constant, of f of x exists. Okay, so we're going to say that this exists, and the following, limit as x approaches c of this thing, k times f of x, is equal to the same thing as if we were to take the limit just of f of x as x approaches c, and then take that whole quantity and multiply it by k at the end. Okay? So that is the constant multiple law. And now moving on. So we have 3 more to go over. So number 3 is called the product law. Okay? So just from the title, these are kind of self-explanatory, or they allude to what is going to be going on from this law. So we're going to say that limit as x approaches c of f of x times g of x exists, and as you might guess, kind of like what the addition one did, what the sum law said, this exact limit up here is going to be equal to, limit of f of x times limit as x approaches c of g of x. Okay? So it's kind of going to be like the same thing, and this is equal to that, so I'll rewrite it here. So this is what we started off with. Okay? Sorry, I wrote it backwards on that one. There. Okay. So on the right side, this is what we have. The limit of the product of two functions is equal to the product of the limits of the two functions calculated separately. Okay, as you see here. All right, so moving on to the 4th one, called the quotient law. Quotient. So here we're dealing with division, right? Just as product is with multiplication, and the sum law is for addition. And the same thing goes for subtraction. There just isn't a subtraction law or a difference law, because it's basically the same thing as the sum law, except for you just have a minus sign in front of the functions. But anyways, okay, so according to the quotient rule, we have so here's another condition, if the limit as x approaches c of g of x is not equal to 0. So first of all, the limit of g of x cannot be 0, because the following is going to be true. So we have limit as x approaches c of f of x over g of x. This is going to exist if the lower limit here, the one on the bottom, the limit of the lower function is not 0, because then if it were 0, then that means that this limit does not exist, because you can't have a 0 on the bottom. So if it doesn't equal 0, if the limit of g of x does not equal 0, then this entire limit exists, and we have another and, limit as x approaches c of f of x divided by g of x is going to be equal to the limit of the top function over the limit of the bottom function, and the bottom function being our g of x. Okay, so basically you can just split up the limit part here. Alright, so now for the last rule. This is called the power rule. Power rule. And power as in exponents. Or exponents. Yeah, exponents. So this one's going to be if p and q, so if the letters or the variables p and q are integers, integers meaning whole numbers, okay, and integers could be negative as well, and q is not equal to 0, so q is a non-zero number, then we have that limit as x approaches c, of course, of f of x raised to some power p over q. Okay, so the power is p over q here. That's the important part. Then this exists, and we have that this limit also equals, so additionally, this limit as x approaches c of f of x raised to the p over q power is going to be equal to the limit as x approaches c of our normal f of x, and then this quantity is raised to the p over q power. Okay? We do have quite a few conditions, or just, not conditions, but different cases that could arise. So this is the basics of the power rule, but we also have, I'll start on this slide here at the bottom. So we do have one, if q is even, so if our number q is even, okay, then we have to assume that limit as x approaches c of f of x is greater than or equal to 0. Okay, and the reason being is because, like, if you have a q on the if you have an even numbered or an even q, basically like a 2 or a 4, like for example, what if you had p equals 1 and q equals 2? Then you had the power of 1/2, which is basically the square root of something. And in order to take the square root of something, it has to be greater than or equal to 0. You can't take the square root of a negative number. That's an irrational number. And then you get the I and the imaginaries and stuff like that. So we don't want to deal with that, so we're basically going to limit it to if q is even, an even number, 2, 4, 6, etc., then our this limit here on the inside has to be non-negative. Okay, it could be 0 or positive number. Alright, so another case that could arise is if our p over q, if the entire exponent is less than 0, so meaning a negative, so that would give you a negative exponent, right? So that means it would be 1 over whatever you get, because we have to flip it to the bottom. Then we're going to assume that limit as x approaches c of f of x is not equal to 0. Because remember again, if we have a negative exponent, that would flip the entire limit to the bottom, so it'd be 1 over something, and we never want a 1 over 0. We don't want a 0 on the bottom, so we're just going to restrict it so that our limit cannot equal 0. Okay, so I have a couple more of these cases, and I'll continue this on the next slide.
Made me sling a chance to dance on a floor, fat lady sing. Murderous servant, hoping one day I may be king. Try and get fly, that's why I played the